Hello, Asako Okechukwu, you're welcome. You're welcome to today's class. Thank you for stopping by. Thank you for coming. Please, can you see the two lines on the board, please? At Osako Okechukwu. Can you see the two lines on the board so we can start? Okay. All right. So let us start. Welcome, everyone. Thank you for coming for today's class. And what we are going to look at this day is GCE questions, physics revision question for those that are preparing for this forthcoming GCE this November and December 2025. Okay, so I'm going to be looking at so many physics questions and the solutions to them. I hope that is clear. All right, I want you to follow us to the end of the class so you can see various ways in which we can attempt physics questions and answers. Is that okay? Right. So let's proceed with number one question. All right, so let's look at this first example. A body of mass 6.0 kg rests on a rough horizontal surface where the coefficient of static friction is 0.25. Determine the magnitude of the limiting frictional force, and we are giving G as 10 meters per second square. Now, the first thing that will come to our mind is frictional force, okay? Let me use the diagram to do an illustration of the frictional force. Now, we have this is a body, and the mass of this body is what? 6.0 kilogram, okay? This is my reaction, and this is my weight. This is, the mass is 6.0 kilogram, 6 kilogram, okay? Then on the horizontal, on a rough horizontal surface, see the horizontal surface. This is horizontal surface, and the coefficient of this friction is what? 0.25. What is the magnitude of the limiting frictional force? Now, frictional force is the force of what? Opposition. The frictional force is going this way, while the direction of motion of this body is going this way. Okay, so frictional force is actually opposing the motion of this. In as much as this is going this way, this direction, this is called direction of motion. Direction of motion. Why this is what? A frictional force. Remember that frictional force acts between two surfaces in contact, okay? And it tends to oppose the motion of one over another. So it tends to oppose the motion of this one over itself. Do you understand? It tends to oppose the motion of this body over another. So going by that, we are going to state the parameters using the law of friction that the frictional force is directly proportional to the normal reaction, okay? That is F is proportional to what? Reaction force. And when we remove these proportionalities and introduce a constant, and that constant is what we say to be what? Mu. That's the coefficient of limiting friction. And that was what has given the question to be 0.25. And we have the weight, which is equal to the reaction. Okay? Now the weight of this body is equal to the reaction. Look at it. Okay? And it is equal to m what? G. Now we are giving the mass of the body to be 6. And we have acceleration due to gravity to be 10. Now we multiply to get what? The reaction. That is, reaction force is what? 6 times 10, and the answer becomes what? 60 Newton. Is that right? Now for us to be able to solve this, we are looking for this frictional force F. How do we solve this problem? Simply by saying that if F is equal to mu what? R. Now what is my mu? My mu is given as 0.25, which is coefficient of limiting friction. So I say 0.25 times what? 60, right? By the time we multiply, with the help of our calculator, we have 60, or we say 0.25 multiplied by 60. So the answer becomes what? That the frictional force is equal to what? 15 what? Newton is equal to 15 Newton. And we have the option A to be 240 Newton, B is 150 Newton, C is 60 Newton, and D is what? 15 Newton. So the answer to this question is what? 15 Newton. Is that clear? So this is how you can solve problem on frictional force. Right. Okay, Afachoma, thank you so much for coming. Peace, Osakwe, thank you so much. Oya Kejagwa, thank you so much for coming. I hope that is clear. All right, so we're going to move to the next question that we have. All right, let's go to the next question. Okay, let me tell you, this should be number 2. A girl of mass 48 kilogram rose up 25 steps. Each of height 0.2 meters to reach the first floor of a story building. If the power expended by the girl is 400 watts, calculate the time taken. And we are giving G to be 10 meters per second square. Okay, so the option we have the options. We have 2 seconds, 3 seconds, 4 seconds, 5 seconds, and 6 seconds. Charles, you're welcome. You're welcome. Thank you for coming. All right, so let's proceed. All right, let's solve this question. A girl of mass 48 kilogram runs up 25 steps, each of height 0.2 meters, to reach the first floor of a story building. If the power expended by the girl is 400 watts, calculate the time taken. Okay, we're actually looking for the time, and we are giving G. What is G? Acceleration due to gravity, as 10 meters per second square. And the option given in this question: A is equals 2 seconds, B is equals 3 seconds, C is equals 4 seconds, D is 5 seconds, and E is what? 6 seconds. Now, the first thing that will come to our mind is power. What is power? Power is the time rate of doing work. Okay? All right. Then what is work? Work is said to be done whenever a force moves its point of application a distance in the direction of the force. So we can say that work is equals to force times distance. Okay? But power is equals to work done over what? Time. All right, the first thing we have to do is to state our parameters by saying that the mass of the body is 48 kilograms. Then, if you hear that this girl runs 25 steps, each of height 0.2 meters. It's just like when you're climbing a staircase that has different heights. For example, you climb this, you keep climbing. Okay, the height from here to here is what? 0.2 meters. And the girl climbed how many? 25 steps. How do you calculate the total height? We have to say 0.2 multiplied by what? 25. Okay, that will give us the height, or the total height that the girl has accumulated. So we can go by saying 0.2 multiplied by 25. So the answer becomes what? 5 meters. Okay, so the answer is 5 meters. Now, the next thing that we have to get is we are giving power to be 400 watts. Okay, and we are giving gravity to be 10 meters per second square. We are looking for what? For time. Now, from our formula, power is equals to mgh all over what? Time, right? Now, what what is my mgh? M is my mass, that is 48 times. My G is 10 times 10. What is my H? My H is 5. Okay? All right? I really, you know how I got that? I can just say, put bracket 0.2 times what? 25. That gave me what? 5. All right. Then I divide it by what? By time, which is what I'm looking for. But do I have power? Yes, I do. What is my power? My power is what? 400. Okay. Now, this will give me, let's multiply this and see what I have. That is 48 times 10 times 5. I have 2,400. This will give me 2,400 divided by what? By time, right? So that is 400 is equals to 2,400 over what? T, right? So if I say cross multiply, therefore, T is equals to 2,400 over what? 400, right? Let's divide. My answer becomes what? 6 seconds. My answer becomes 6 seconds. That means the correct option is option what? The E. Let me go again by explaining that the mass of the girl is given as 48 kilograms. Then for us to get the total height, because the girl climbs 25 steps and each of height is 0.2. For us to get the total height of the girl, we are going to say 0.2 multiplied by 25, and the answer becomes what? 5. And from the question, we are giving power to be 400 watts, and we are giving G, which is 10 meters per second squared. So we are asked to calculate what? The time. Then from the formula, the power, and I already explained what is power. Power is time rate of doing work, okay? Power is time rate of doing work, and what is work? Work is force times distance, okay? Now, you can say that power, P is equals to mgh over what? Over T, right? Now, by the time you substitute our values, we got our answer to be 6 what? Seconds. I hope that is clear, right? All right, so let's go to next question. Let's go to our number 3 question. All right, let's look at another question. That's question 3. The real I have an option. All right, let's look into this question. The real and apparent cubic expansivities. The real and apparent cubic expansivities of a liquid in an expansible container are 3.0 times 10 raised to power minus 6 per Kelvin and 1.6 times 10 raised to power minus 6 per Kelvin, respectively. Calculate the cubic expansivity of the material of the container. And we're giving these options. Now, the first thing that will come to your mind is, what is real cubic expansivity? What is apparent cubic expansivity? Okay, the real cubic expansivity is the increase in volume per unit volume per degree rise in temperature. Okay, while apparent cubic expansivity is the increase in volume per unit volume per degree rise in temperature when the body is heated in an expansible what? Vessel. For example, if you are heating a liquid in a container that is like this is the liquid, this container, this liquid, okay. Now, if this container is an expansible vessel, you know what is an expansible vessel? A container that can expand when heat is attached to it. Now, if this container is heated, the liquid inside will heat up and increase, while the container will also do what? Increase. Okay, so how do we check the real expansivity of this liquid? For us to calculate the real expansivity of this liquid, we're going to say that is the apparent expansivity of the liquid inside this container added to the expansivity of the container. Okay, so that is what we are using to solve this particular problem. Now, we are saying that the real cubic expansivity is equals to apparent cubic expansivity plus what? Expansivity of the container. Now, we are going to use that to solve. In the question, we are giving the real cubic expansivity to be what? 3.0 times 10 raised to power minus 6. If you hear respectively, it means the real cubic expansivity is this, while the apparent cubic expansivity is this, because they respect each other, okay? That is what the word means, respectively. So let's go. The real cubic expansivity is giving us 3.0 times 10 raised to power minus 6 per Kelvin. Okay. Then the apparent cubic expansivity is giving us 1.8 times 10 raised to power minus 6 what? Per Kelvin. And we are looking for expansivity of the container. Okay. Now, for us to do that, we are going to say, since we are looking for this, that is our gamma is equals to what? Real cubic expansivity minus apparent cubic expansivity. Now, see what I did. By carrying this apparent cubic expansivity, that is gamma A, to this other side, okay? Once I carry it to this other side, I'm going to change from plus to minus because I'm looking for the expansivity of the container. All right? Okay, so let's go by that. We say expansivity of the container is equals to 3.0 times 10 raised to power minus 6, then minus 1.8 times 10 raised to power minus 6. Okay, now let us subtract. We go by saying 6 exponent minus 6 minus 1.8 exponent minus 6. So my answer becomes 1.2 times 10 raised to power minus 6 per what? Per Kelvin. So the expansivity of the container equals 1.2 times 10 raised to power minus 6 per Kelvin. So the answer to this question is what? Option what? B. which is 1.20, which is same thing as 1.2 because 0 means nothing, times 10 raised to power minus 6 per Kelvin. Is that clear? Do we understand? So when you have this such question, what you are going to do is to state your parameters, knowing fully well that you're looking for the expansivity of the container. Then we substitute in by stating our parameters, then make whatever thing you're looking for the subject, and you see your answer in front of you. Right, let's move to the next one. All right, so let's move to the next question. Let's move to the next question. It's question 4. All right, that's question 4. When brass of length 10 centimeters at 50 degrees C is heated, its length changes to 100.054 centimeter at what? We are given inexpansivity of brass as 0.000018 per Kelvin. And the options we have, A is 51 degree, B is 54 degree Celsius, we have C at 72 degrees Celsius, D is 80 degrees Celsius, and E is 82 degrees Celsius. All right, now let's look into this example. When brass of length 100 centimeter at 50 degrees Celsius is heated, its length changes to 100.054 centimeter at dash. They want us to get the temperature, the second temperature, the final temperature, in which the body increased to 100.05 centimeter. Okay, and we are giving the linear expansivity as 0.00018 per Kelvin. Now, the first thing that will come to your mind is linear expansivity. If you are asked what is linear expansivity, linear expansivity is the increase in length per unit length, a degree rise in temperature. So when a body increases in its length, it's said to be linear expansivity. Okay, and its magnitude is given by what? Alpha. And alpha is equal to L2 minus L1 all over L1 what? Bracket theta 2 minus what? Theta 1. Okay? Now, we have the linear expansivity given. We have the new length, which is 100.054 centimeter. We have the original length. Okay? We equally have the initial temperature before heated. We're looking for the final temperature after heating. Okay? Now, look at what we have. This length 100 degrees Celsius is the original length. At 100 degree this length 100 centimeters is the original length. So at 100 centimeter, this body has not been heated, okay? And the temperature is remain steady to be what? 50 degrees Celsius. As soon as the body was heated, the length changes to what? 100.054 centimeters. Now you're looking for the new temperature that made the object to increase to this level. Is that okay? That is what we are looking for. So can we set the parameters? We have our L1 to be 100 centimeter, L2 to be 100.054 centimeter. Okay, so we have theta 1. We have theta 1, that is 50 degrees C. We are looking for theta 2. We have alpha to be 0.00018 per Kelvin. All right. Let's solve and make theta the solver. Let's see what we'll have. So my alpha is this. I can actually use this formula, but let me continue with this one. My alpha is 0.00018 is equals to my L2, that is 100.054 minus 100, okay? Then divided by my L1 is 100 bracket. My theta 2 is what I'm looking for, minus 50, which is my theta 1, okay? So I'm going to work it out and see what I have. All right, so this is 0.00018 is equals to, by the time you subtract 100.054 minus 100, the answer is going to be 0.054, okay? That is the numerator. Then we divide by what? We divide by 100 bracket theta 2 minus 50. Is that clear? So the next thing we are going to do is to say that this is over 1. So we can do cross multiply. So if we do cross multiply, what do we have? Okay, so we multiply by saying, let me just multiply it out. 0.00018 multiplied by 100. Okay, so I have I will have 0.054, okay, is equals to 1.8 times 10 raised to the power minus 3 bracket what? Theta 2 minus 50. Now see what I just did. I multiplied this 0.00018 by what? By 100 to get this, okay? Then the next thing I did was to retain this in bracket because I'm going to open the bracket soon. Then 0.054 multiplied by 1. I have this. So what do I do next? Is to open the bracket by saying 0.054 is equals to 1.8 times 10 raised to the power minus 3 theta 2 minus, let me multiply to see what I have, times 50. I have my answer to be 0.09, okay? Then if I take 0.09 to this, I'm going to add, right? So let's go. 0. Let me see. Who's calling? All right. I want 0.054 plus 0.09. That is, I'll have 0.144 is equals to 1.8 times 10 raised to the power minus 3 theta 2. Then I divide both sides by what? 1.8 times 10 raised to power minus 3. 1.8 times 10 raised to power minus 3. This will cancel. Okay. Okay, let's go. 1.8 exponent minus 3. All right. So by the time you divide, I don't have enough space. My teeth is going to give me what? 80 degrees Celsius. Because this will cancel, this will be left with theta 2. By the time you divide 0.144 divided by 1.8 times 10 raised to power minus 3, the answer is going to give you 80 degrees Celsius. And the answer to this question is what? D. Alright? So this is how you can solve problem on linear expansivity when you are looking for the new temperature. Is that clear? Alright, so let me do a recap. When a brass of length 100 centimeter at 50 degrees Celsius is heated, okay, this length changes to 100.054 centimeters at dash. So I'm looking for the temperature, that is the new temperature, okay, or the final temperature. Then we are given the linear expansivity of brass to be this. And the first thing is to set our formula, then set our parameters we have. Now this is what we're looking for theta 2. We substitute everything and try as much as we can to make it the subject. And the question is, why don't we convert centimeter to what? To meters. We don't need to convert centimeter to meter in this question because centimeter cancels centimeter and the answer becomes per Kelvin. That is for linear expansivity. So on that note, that was why we don't always convert questions on linear expansivity to changing from centimeter to meter. Whichever way be the answer question is still going to cancel each other, right? Okay, so this is what we have, and the answer to this question becomes what? 80 degrees Celsius. Is that okay? Right. All right, so let's move to the next question. All right, I hope that question is clear. So let's go to the next one. That'll be our question 5. All right. All right. Now, let's solve this problem. A spring of force constant, 200 Newton per meter, is compressed through a distance of 5.0 times 10 raised to power minus 2 meters. Calculate the energy stored in the spring. Okay? Now they will lead us to Hooke's law, elastic constant. Okay, before we can get to what the energy stored in the spring. Okay, now if I refer to Hooke's law states that provided that the elastic limit of an elastic material is not exceeded, the extension E is directly proportional to the applied force F. Okay, so that is F is proportional to what? E. And remember that in every law in physics, we must remove this proportionality sign to introduce a constant by saying that F is equals to what? K what? Ke. Is that clear? All right. So, but the energy stored in the spring is the same thing as work done. In case you are asked, okay, is equals to half Fe or half Ke what squared. Okay. So we're going to state the parameters given. Let's see the equation that will fit into what we have. So we are given a force constant, which is K. K is force constant. Is given as 200 Newton per meter. Okay. Then it is compressed through a distance of 5 times 10 raised to power minus 2 meters, which is my extension. Okay. So from what I have, the formula that will suit this is what? This second one. So I'm going to apply it by saying that E, which is the energy, is equals to half Ke what? Squared, right? What is my K? My K is what? 200. What is my E? My E is what? 5 times 10 raised to power what? Minus 2. Remember, it is squared. Okay? Squared is the same thing as saying multiply it twice. But I can just say what? All squared. Is that okay? So, I will say E is equals to what? If this cancel itself 1, if 2 cancel this, I have 100. So, this is 100 multiplied by, let me say, 5 exponent minus 2 all squared. I'm going to have 2.5 times 10 raised to the power of minus 3. Okay? So by the time I multiply, I say 100 multiplied by this. So let me see what I have. I will say 100 multiplied by 2.5 times 10 raised to the power minus 3. All right, so let's go. 100 multiplied by 2.5 exponent minus 3. Okay, so my answer becomes 0.25 what? Joules, right? So the answer to this question is 0.25 joules. Let me do a recap. We are given a spring of force constant to be 200 Newton per meter. It's compressed through a distance of 5.0 times 10 raised to the power minus 2 meters. Calculate the energy stored in the spring. And this energy stored in the spring is taking us back to Hooke's law. And we have that energy stored is equals to half Fe or half Ke squared. What is F? F is force and E is extension. K is what? K is the force constant, or we call it stiffness. Okay? So we are giving K to be 200 Newton per meter. The extension to be 5 times 10 raised to the power minus 2 meters. Then we have what? Our formula. We substitute it into what we have. Remember that if this extension is given in centimeter, you must convert it to meters by dividing by 100. Or if it is given in millimeter, you must convert it by dividing by 1000. Okay? So that is what we have. I got our answer to be 0.25 joules. I hope that is clear. Right. Fochema, you're welcome. How are you today? All right, if you have question, you can drop it, okay? If there's no question, we'll move ahead to solve more problems. All right, let's move to the next one. Question 6. Let's go to question 6. All right, let's look at this question. A wire of length 2.00 meters and radius 1.0 millimeters is stressed by 25 millimeters on application of a force 10 power 3 newtons. Calculate the Young's modulus for the wire. Now, for us to know what is Young modulus, I'm going to go back to do a recap of what is Young modulus. Okay? Starting from Hooke's law. Hooke's law states that what? Provided that the elastic limit of an elastic material is not exceeded, stress is proportional to what? Strain. Okay? That is stress is proportional to what? Strain. Okay? Then stress is equals to, this is a constant, strain, right? I want to make it the subject, I divide by strain. So this is stress, this is strain, right? I cancel this. So y is equals to what? Stress over what? Strain. And this is what is said to be our Young's modulus. Okay? Now, what is my stress? My stress is force over what? Area. Sorry, my network. Okay, so let's proceed. All right, so let me go back. Now I have that from Hooke's law, that stress is proportional to what? To strain, okay? Then, when we remove this proportionalities and introduce a constant, that is y, okay? Then it means that stress is equal to y was strain, right? Now I want to make this the subject by dividing both sides by what? Strain and strain, right? We cancel. So what is my y? Is equal to stress over what? Strain. So this y is what we say to be my Young modulus, right? Now this is equal to force over area. What is force over area? Stress is equal to force over area divided by strain is equal to extension over what? Length. Okay? Then I'll go by saying Young modulus is equal to force over area multiplied by what? This one will come up, will have what? Length over what? Extension. Right? So this is the formula we're going to use to solve this our Young what? Modulus. Is that okay? Right. Let's proceed. So let's proceed. Let's proceed and solve our problem. I just explained the theory behind what we are doing. So let's solve the question right now. All right. Now let's solve a wire of length 2 meters. So the length is 2.00 meters and radius is 1.0 millimeter. Okay. Now it is stretched. This is the extension E. Once you hear stretch, the length will increase. That becomes extension. It's being extended, okay? So it's giving us 25 millimeters, right? By the application of force, which is 10 power 3, which is the same thing as 1000 Newton. And before we can solve, the first thing that will come to our mind is for us to do our conversions. We must convert this millimeter to meter by dividing by 1000. Okay? So we say that this is 1 over 1000, which will give me 1 times 10 raised to the power minus 3 meters. Is that okay? Now this is 25 over 1000. This will give me what? 2.5 times 10 raised to the power what? Minus 2 meters. So let's confirm with the calculator. Okay, so we are correct. Now, one thing that we don't have in this question is area. There's no area, but we can use the area of a wire to be what? Pi r squared, right? Now, what is pi? Pi is 22 over 7, of which when you divide, it becomes 3.142. So we can substitute it to get that. Now, we say A is equals to, what is pi? My pi is 3.142 times, what is r? 1 times 10 raised to the power minus 3 all squared, right? So my area is 3.142 multiplied by the time you square it, you have 1 times 10 raised to the power minus 6, right? It becomes meter square now. And by the time I divide, I'm going to get my area to be 3.142 times 10 raised to the power minus 6 meters squared. Is it clear? I hope you can see it clearly. All right. All right. So the next thing I'm going to do is to use the formula of my Young modulus, because that's what I'm looking for. My Young modulus y is equal to what? Stress over strain, okay? Is equal to stress over strain, right? Now, if I substitute into the formula, I have force over area divided by extension over length, which will give me cross multiply force multiplied by length all over area multiplied by what? Extension, right? Okay, let's put in what you have. What's my force? My force is 1000. 1000 multiplied by my length is what? 2 meters. Then divided by my area is what? 3.142 times 10 raised to the power minus 6 multiplied by my extension is what? My extension is 2.5 times 10 raised to the power minus 2. Okay. All right. Let's work it out and see what we have. Okay. Exponent minus 2 is equals to this, then 2000 divided by answer. So my answer to this question becomes 2.55 times 10 raised to the power what? 10 Newton per meter square. Okay. All right. So the first thing you have to do in this type of questions is to state your parameters and do your conversions where necessary. And remember that we don't have, we are going to find area. Our force is 10 power 3, which is the same thing as 10 times 10 times what? 10, which gives rise to 1000 Newton. Now my area is pi r squared. Okay. Now what is my pi? My pi is 3.142, although the same thing as 22 over 7, multiplied by this, my radius, which is 1 times 10 raised to the power minus 3, all what? Squared. So by the time you substitute into what we have, you got your area to be 3.142 multiplied by minus 6 meters squared. Is that clear? All right. For us to remember that stress, Young modulus is equals to stress over what? Strain. Okay, you can still going to see it as tensile stress over tensile strain. They are still saying the same thing, okay? And the stress is equal to force over area divided by what? Extension over what? Over length, okay? Now, by the time you multiply, you have force times what? Length divided by area times what? Extension. You substitute it into our values, what we have, then our answer becomes 2.55 multiplied by what? 10 power 10 Newton per meter square. Is that clear? Right. All right, let's move to the next question. Okay, so let's go. Number 7. All right. So let's look at this example, question 7. What is the length of closed pipe? Okay. What is the length of closed pipe that will produce a sound of fundamental frequency of 150 Hz and the speed of sound in air is given as 330 meters per second, right? Now, there's one thing we must note about a closed pipe. Once you hear a closed pipe is a pipe that is closed at one end. For example, flutes, trumpet, okay? Any instrument that you can blow air through to produce sound said to be what? A closed pipe, okay? Now, if the both ends are open, becomes an open pipe. But in as much as you're going to blow air through one side, to blow air and to produce sound through the other side, it's said to be what? A closed pipe, because it's a pipe that is closed at one end. All right? And the fundamental frequency of a closed pipe is given by the fundamental frequency F naught is given by what? V over what? 4L, right? Right? Remember, from the speed of sound, F is equal to what? V over what? Lambda. But because in the harmonics and overtones, we have that the distance into the sound has traveled is equal to what? 4L, right? Okay, remember that the distance between node and another node is lambda over 2. Distance between node and antinode is lambda over 4. Is that clear? So we're going to use this to solve. Now we are given the fundamental frequency F naught to be 150 Hz, right? Now we are looking for the length, okay? And we have the speed of sound, which is 330 meters per second. And we have the following options. A is 50 centimeters, B is what? 55 centimeters, C is 73, D is 100, and E is 110 centimeters. So let's solve and see the one that will give us our answer. All right. Now let's go. We have this. Our F naught, which is fundamental frequency, is 150 is equals to, my V is 330, okay, divided by what? This is 4L. And we are looking for what? L, right? And I will just say this is over 1, cross multiply, that is 150 times what? 4L is equals to 330, okay? So 150 by 4 is going to give me 600, so I will have 600L is equals to 330, right? Then I'll divide both sides by what? By 600 by 600. This cancels this. So my L, let's go by saying 330 divided by 600. I will have 0.55 meters, right? Okay. Since it is in meter and I want it to be in centimeter, I'm simply going to multiply by what? 100, okay? And my answer for L is equal to 55 centimeters. Is it clear? Let me do a recap. The fundamental frequency of a closed pipe, F naught, is equal to V over what? 4L, right? Now F naught is given as 150 Hz. We're looking for the length, and we have the speed of sound to be 330 meters per second. Now using this formula, we substitute it into what we have. F naught is given as 150 over 1, right? Then it's equal to 330 over 4L. Now we'll do cross multiply and make it a subject, and our answer becomes what? 0.55 meters. But because I want the answer to be in centimeter, I multiply by 100, and my answer is equal to what? 55 centimeter. And the answer to this question is what? B. Is that clear? Right. All right, let's move to the next question. That is question 8. All right, so let's look at this question. The resistance of a wire of 0.6 meters and diameter 0.2 millimeters is 2.0 ohms. Calculate the resistivity of the wire. Let's go again. The resistance of a wire of 0.6 meters and diameter 0.2 millimeters is 2.0 ohms. Calculate the resistivity of the wire. Now, for us to do this, we should remember that there are two factors that affect the electrical resistance of a wire. Okay? Length, the area, the temperature, and the type of material. Okay? Now, we should know that the resistance varies directly as the length, then the resistance is inversely as the what? As the area. Okay? By the time I combine them together, I'm going to say that resistance varies directly as the length and inversely as what? Area. Right? This is possible, right? Okay? Now, if I remove this proportionality sign, I introduce a constant, then resistance is equal to rho L over what? A. Now, what is this constant? This constant is what is said to be the resistivity, okay? But let's make it the subject by doing this is over 1 cross multiply, right? Okay? Rho L is equal to R what? RA. Then I divide both sides by L. I cancel, okay? So my resistivity is equal to what? RA over what? Over L. Is that okay? And that is why the unit is what? Ohm meter. How is the unit ohm meter? The unit, this is measured in ohm, this is measured in meter square, this is measured in meter, right? Now this will cancel each, and the unit of this becomes what? Ohm meter. That is the unit of resistivity. Is that clear? So this is the formula I'm going to use to solve what you are actually looking for. Is that clear? Right. All right. So let's put in our values and we solve our problem. Now let's substitute what we have. The resistance of a wire of 0.6 meters, that is my length, which is 0.6 meters. And we have diameter D, to be 0.2 millimeters. Okay, then we have the resistance R, okay, to be 2.0 ohms. Now, how do we solve for this resistivity? Rho is what you are looking for, right? But we don't even have area. So we need to find our area first, right? And we don't even have radius because area is pi r squared, but we don't even have radius. So we say the radius is diameter over 2. That is 0.2 over 2, right? That will give me 0.1. But remember that it is in millimeter. There is need for me to convert to meters, right? And I'm going to do that by dividing by 1000. So I'll say R is equals to 0.1 over 1000. What do we have? We have 1 times what? 10 raised to the power of minus 4 meters. Okay? Now, let me solve for the area. What is area? Area is what? Area is pi r squared. Okay? Now, what is pi? Pi is 22 over 7 or 3.142, right? 3.142 multiplied by, what's my r? I have 1 times 10 raised to the power minus 4 all squared, right? Okay? So, I will say this is 3.142. If I want to square, I'm going to have 1 times 10 raised to the power minus 8, right? Okay, so I'll multiply all through now to have that A is equal to 3.142 times 10 raised to the power minus 8 meters squared. This one is just for us to get the area. So now we can what? We can solve. So let's go. Resistivity, remember the formula is equal to RA over length. So I will say RA over L. What's my R? My R is 2 multiplied by, my area is 3.142 times 10 raised to the power of what? Minus 8, okay? Then divided by what? My length is 0.6. 0.6. Okay? So let's multiply. Okay, this will give me 6.284 times 10 raised to the power of minus 8 divided by 0.6. Okay? So 6.284 exponent minus 8, right? Then divided by 0.6. Okay, so my answer will be 1.047 times 10 raised to the power minus 7. So approximately I will have 1.05 times 10 raised to the power minus 7 ohm meters. That gives us the unit of what? Resistivity. This is approximately, so I approximated this value to get me this, right? So let me do a recap. The resistance of a wire of this length 0.6 meters, this is diameter 0.2 millimeters, is 2.0 ohms. Calculate the resistivity of the wire. Now for us to do that, we set our parameters, and the first thing to do next is to combine this radius together, our radius rather, because we have diameter, okay? Because you can get diameter, you can get radius from diameter because this is a circle. This line is said to be our diameter. When we divide it by 2, we have what? Radius, right? So 2 radius is equal to diameter. So radius is diameter divided by 2, okay? That's what I did, right? To get radius, and I got it at 0.1 millimeters. Remember that I must convert this millimeter to meter just by dividing by 1000, and I got 1.1 times 10 raised to the power minus 4 meters. Okay, so what's my area? My area is pi r squared. What's my pi? 22 over 7, which is the same thing as what? 3.142. right? Then I multiply by this radius, which is 1 times 10 raised to the power minus 4 all squared. By the time I square it, I have 1 times 10 raised to the power minus what? 8. Okay? Then I'll bring it down. My area becomes 3.142 exponent minus 8 meters squared. That is just my area. Then for me to solve for resistivity, I have rho is equal to RA over what? Length. Now I substitute everything I have, and my answer becomes exponent minus 7 ohm meter, and that gives us the value of our resistivity. Is that clear? Right. All right. So we should be done now. Let's move to the next one. All right. All right. We have this diagram on the board. It says name the three basic components P, P, Q, R that make up a cathode ray tube as illustrated in the diagram above. This is what we call cathode ray oscilloscope. This diagram is called cathode ray oscilloscope. Cathode ray oscilloscope. Okay. Now, they are the basic components in this circuit. The same, initial is CRO. Some people can call it a cathode ray tube. Okay. All right. So the basic component of this is this. This is what we say to be what? Deflector plate. This electron gun, deflector plate, and what? And the screen. And I'm going to explain what it is used for. Right? Okay. All right, so this CRO or this cathode ray tube is an application of what? A diode valve, okay? A diode valve. And a diode valve it operates from the principle of thermionic emission. Diode valve operates from the principle of thermionic emission. What is thermionic emission? It's the emission of electron from the surface of a hot what? Metal, okay? When a hot metal is heated, electron tends to do what? Emit from its surface. Electron tends to go off to release, to leave the surface of the hot metal because it was what? Heated. So this is what is said to be our heated filament, which is also the same thing our what? As our cathode. This is what is said to be heated filament, which is also the same thing as our what? This fluid can be our cathode. Okay. Now this is what we call grid. The thing that distinguish between cathode and what? Anode. And this is what this one is said to be what? My anode. All right. Now I'm still going to explain the principle of this CRO. Now this is what is said to be the deflector plate. It tends to deflect the plates of this tube vertically and what? Horizontally, okay? Vertically in the what? Vertically in the YY what? Prime, and horizontally in the what? SS prime. Alright? Now this screen is where the radiation, the image is formed here. The image of this movement here is what? Formed on the screen. Now, what is the purpose of this heated filament? This heated filament, it is heated because it is usually connected to an AC source, okay, and it generated current from there. Now, once current is coming from this axis, this cathode will be what? Will be heated, okay. Now, if this cathode is heated, current will be flowing only in one direction, only in one what? Direction, which is through the what? Through the anode. Now I'm going to draw a diode valve and explain the principle of diode valve that leads to the principle of this CRO. So now what is a diode valve and why a diode valve allows current to flow only in one direction. Okay. Now if current flows in this direction, we can now say that this does not obey Ohm's law. All right, because a non-ohmic conductor does not obey Ohm's law because current flows only in one direction. All right, so I'm going to rephrase this diagram and explain further. Is that clear? Right. Neka's Corner, thank you so much for coming. I really appreciate. All right, so let's go into diode valve. Let me sketch diode valve and explain from there. All right, this is a diode valve. What is a diode valve? This diode valve uses the principle of thermionic emission. And I said, what is thermionic emission? It's the process of emission of electron from the surface of a hot metal. It's the process, or we can say it's the emission of electrons from the surface of a hot metals. Now, if this is the heated, this is the filament, which is also the same thing as the heater. Once it is connected to a DC source that has positive and what? Negative, right? Direct current. And the current flows. Once this heater is heated, this is just like bringing your boiling ring and doing what? Put it in the switch, then on it. What happens next? Switch it on. What happens next? You're going to streams of what? Electron. Okay? Now, this electron that's coming out from this filament, which is also the heater, you now come here and land on the what? On the cathode. Cathode is a metal plate. Anode is a metal plate. Okay? But because this anode, it is a positive electrode. It is a positive electrode. It is a positive electrode. So current tends to flow, electrons and current will now flow from this cathode and move towards what? Towards the anode. Why are they moving from here? Because this is the source of the heat. This is the source of the heat. Now it's bringing out the heat from here and it heated up the cathode. Okay? So current, electrons and current will now flow and flow through where? Through the anode. Because this anode is made a positive electrode. Now, because this cathode is producing the heat, current cannot flow back. I don't know if you get it. This cathode is producing the heat, so current and electron cannot flow back because it is one producing it. So it's going to flow outside, that is emission. It's going to emit from the surface of this and flow through this direction. Okay, so now current is now flowing only in one direction, this way, to the entire what? Circuit. To the entire what? Circuit. You understand what I mean by that? Because this is made the positive electrode and cathode is producing the heat, current can only flow in one what? Direction. It can only flow in one what? Direction. So because current can flow in one direction, it is said to be what? A diode. It is said to be what? A diode, because a diode allows current to flow only in one direction. And this is why current flows in one direction, because current is coming out from the cathode. Now it must move through this because it can't go back from where it came from. So as it's emitting, it will move through the what? Through the anode and circulate. Do you understand? It will not be recorded in the what? Milliammeter and what? And the potential difference, which is voltmeter. Alright? That leads us to what we say to be the VI characteristics. You see the anode characteristics. You see this? Okay? You have current like this. Now this is a jam question. They will sketch it and ask you which one is correct. They are working on the principle of this diode valve. Of current will flow in only in one direction. And this is why current flows only in one direction. Because the cathode is one producing the heat. So the current cannot flow back because it's already emitted. So the electron is going to move from here to the cathode. And it's recorded in the ammeter and also in the voltmeter. Okay? And when such current is being recorded, we can now be able to check the movement of the current and the potential difference. Is that okay? So diode does not obey Ohm's law. It can act as a rectifier for converting AC to DC. It does not obey Ohm's law. That is just it. Because in Ohm's law, current flows in both directions. But in diode valve, current flows only in one what? Direction. And you already know why it flows in one direction, because cathode is producing the heat, so it's supposed to flow only in one direction. Is that clear now? So that is the principle that CRO uses to operate. Is that clear? Hope you have gotten the picture. Right. If you have question, you can drop it. Let me see it if you don't understand what I just explained. Okay. All right. So let's move to the last question for today, which is question what? Question 10. All right. Let's go to the last question for today. All right. Now look at this question on the board. Let me just write this question. Calculate the total distance traveled. Okay. All right. Before we could solve this, we are going to put so many things into consideration before we can talk of solving this. This is a velocity time graph question. And we are going to use the knowledge of our speed, velocity, and acceleration to solve this. Right? Okay. So let's quickly move into the solving. We are asked to calculate the total distance traveled from this to this. We are given this velocity time graph. This is an acceleration of a body start from rest or accelerate from rest. This is 0. The first acceleration was given as 6 meters per second square. Later, the acceleration was reduced to 4 meters per second square. Okay, with different times stated. We are asked to find the total distance traveled. Now, we don't even have the initial velocity and the final velocity. So let's say we are looking for V1, we are looking for what? V2, right? Now let's go. For us to get V1, we are considering this triangle. This is a triangle, right? From here to here, that's what we are considering. Now, using equation of motion. You know the first equation of motion that we have? V is equals to U plus AT, right? Now this V here becomes my V1 because I'm looking for it. If a body accelerates from here to here, the acceleration here is 6 meters per second square, and the time is what? 20. Okay? And if the body starts from rest, that means my initial velocity U equals 0. So V1 is equals to U is 0 plus my A is 6 times my time is 20. Okay? So I will say that this is equals to 6 times 20 is going to give me what? 120 meters per second. That is my V1. So if my V1 happens to be 120 meters per second, if I want to get the maximum velocity, what do? I will now consider from here to here. Okay? From here to here. So if I consider from here to here, this becomes my initial velocity, which is V1. Okay? And I've gotten it to be 120 meters per second. Why this become my final? Let me go again. If I'm considering the final velocity, which is V2, I'll consider from here to here, and as this becomes my initial, why this become my final? This is initial, this is final. And the acceleration is what? 4. And the time is different between this and this, right? This should be 10. Okay? So using same equation of motion, using V is equals to U plus AT, okay? In this one, I'm looking for V2 is equals to my initial velocity, which becomes my V1, is what I got to be 120 plus. My acceleration is 4, multiply, my time is what? 10, okay? So I have V2 is equals to 120 plus what? 40, and my answer is equals to 160 meters per second. This becomes my maximum what? Speed. Okay? So I've gotten my V1 to be 120 and my V2 to be what? 160. Is that clear? Now this will give us an edge for us to solve for the total distance traveled. And remember that we are going to solve it separately. This is x1, x2, and x3, right? This is the shape of triangle, the shape of trapezium, and the shape of what? rectangle. Is that clear? Now, before I can do that, I have to label it. I have to label it by saying that this is what? A, B, C, D, E, and what? F. Okay? So put it down or ask your question so I can proceed in solving for the distance traveled. All right. Okay, let's proceed. Now I'll write what I got here, which is 120, while this is what? 160. So let's solve. So my x1 is what? Area of triangle, right? Which is what? Half base times height. What is my base? Sorry, what is my base? AF, and my height is what? EO. So I go AF times FO. Okay? Now this is my what? Base. Why this is my what? Height. Now we say half times. Okay, I will come here and say 120 minus 0, that is 120 multiplied by, the difference in time is what? 20, okay? By the time you divide this, you get what? You get 10. So, 10 multiplied by 20, S1 is what? 1200 watts, meters. Is that clear? Now, S2 is the area of what? A trapezium. This trapezium is bending, it's like a side, one side is removed. Well, these are the two bases, AF and BE. They are the two bases. The height is what? EF, right? So let's go. You say this is half bracket AF plus BE, okay, bracket EF. Now that is the formula. All right? If I decide to put it into what I have, okay, let's go. What is my AF? My AF, okay, you come here, that is 120 minus 0. You get 120 plus my BE. You come this way, that is 160. 160 bracket. My EF, difference between this and this is what? 10. So this will cancel to give me 5. Now when I add, I will have what? I will have 280 multiplied by 5. So the answer is going to give me what? 280 times 5. I'm going to have 1,400 meters. That is for this. Then for me to get the last one, S3, I have area of a rectangle. Area of rectangle. Which is length times breadth. The length is what? DE multiplied by what? BE. I can say CD, I'm still correct, okay? So what is my DE? What's the difference? 60 minus 30, that is 30, multiplied by what? BE. That is 120, 160 minus 0. 160, right? Then let's multiply and see what we have. 30 multiplied by 160, I will have 4,800 meters. Now I've gotten the different distances traveled. Then for me to get the total distance traveled, I'm going to add them together. The total distance traveled is equal to what? X1 plus X2 plus S3. Okay? That is 1,200 plus what? 1,400 plus 4,800. Okay? So let me add together. 1,200 plus 1,400 plus 4,800. So the answer to this question is 7,400 meters. Is it clear? Right. Please, if you are just joining us, give it a thumbs up. Thank you so much for coming. All right. Is the question cleared? Are you cleared now? I'm going to review it by explaining it again. All right. So let me explain. I've gotten the two velocities, the initial and final, okay, and the maximum velocity. This is the shape of a triangle, trapezium, and what? Rectangle. So the area is, I'm using the area for the distance, is area of triangle, which is half base times height. Okay. So what's my base? I'm considering this triangle. So everything here, what's my base? My base is this. That is what? 120, and my height is what? 20, okay? Then I'll divide and got my S1 to be 1,200. Then S2 is the area of a trapezium. What's the trapezium? Look at it. This is AF, half AF plus what? BE. Then multiply by what? EF. And that is what I just did. So this is half bracket. My AF is 120 minus 0 plus my BE is what? 160 minus 0. Okay. Then my EF is difference between this and this, which is what? 10. Okay. Now what do I have? I say this is half multiplied by what? When I add this, I got 280 multiplied by what? 5. My answer becomes 1,400 meters. Right? Then coming to the last one, which is area of a rectangle. Okay. So I have length times breadth. So my length, I can use any of them as my length. My length is what? DE. Okay. Then my breadth is what? This, right? Okay. So what do I have? The difference between this and this is 30. The difference between this and this is what? 160. I multiply to get 1,800. Then the question says you find the total distance traveled in the diagram given. So we're going to solve by adding x1 plus s2 plus s3. And we have 1,200 plus 1,400 plus 1,800. And my answer becomes 7,400 meters. Is that clear? So this is how to ask to solve problem under this. They can even ask you to find the total the total speed. Okay, know that speed is distance over time. This is the distance covered. Then the time from here to here is 60 seconds. By the time you divide it by 6, you get the average speed covered for this journey. Is that clear? Do you understand? Right. All right, we have come to the end of today's class. If you are joining us for the first time, please don't forget to subscribe to this channel because we'll be bringing up more likely exam questions you're going to expect. If you are writing this forthcoming GCE 2025 this month, physics is by December, okay? So if you are writing this and if there's any question you want me to explain for you, you can drop it in the comment section. I will see it and I'll do just that. Is that okay? Then see you next time in my next one. Bye.